Hello, we are from SMA Solution. Today we're going to talk about patient of antihypercholesterolemia from the extract of rambutan leaf Nephelium lapaceum. Let's begin with the background of this research. Firstly, hypercholesterolemia has caught our attention from how it can easily happen to anyone. People tend to have bad lifestyle like smoking or eating junk food, which may increase the LDL level. Hence, it will have high cholesterol. Furthermore, it can cause atherosclerosis. Secondly, in Indonesia, based on Kemenkes, we may know that on average, 52.3% of people have high cholesterol. This problem catch our attention again and motivate us to find a solution to this problem. Thirdly, the unexpected event of the COVID-19 pandemic forces us to quarantine ourselves and prevent outside activities. Fourthly, the solving problem are the HMBC or reductase inhibitors that reduce cholesterol levels. The example is statin. Lastly, as well, all know that rambutan is one of the fruit that can be seen everywhere. However, the leaf tends to be unused and left to wilt. Let's move on to the problem statement. The problem that needs to be fixed is the disease of hypercholesterolemia. There are a few factors that can increase the risk of this disease, as mentioned before, like eating junk food that is rich in fats and cholesterol. The formation of atherosclerosis by hypercholesterolemia can cause complication of CVD by blocking the blood vessel pathways. Rambutan leaves are also one of the problems because the fruits can be found and consumed a lot in Asia. However, the potential leaf containing secondary metabolites that may be able to solve certain diseases are unused. The purpose of our research as follows. First, to identify the secondary metabolites present in rambutan leaves. Second, to test the hypercholesterolemic potential of extracted secondary metabolites compound using the in vitro method. Let's talk about the making of the extract. Firstly, we will make the simplicia powder by obtaining the leaf from the rambutan leaves, separating them from the fines and washing them clean. Then leave them for dry for 72 hours under black cloth to prevent direct contact with the sun. After that, grind them and strain them until we get the simplicia powder. Secondly, to obtain the wet extract, make a model of 2 plastic bottles connected with an infusion set and measure them for a few days. Finally, after getting the wet extract, water bake them for a whole day to get the fishes extract. In order to identify the secondary metabolites, we use reaction and instrumentation. To identify flavonoid, we use the test by adding extract and distilled water to test tubes. Then add FCl3, and if the color turns black, then it contains flavonoid. In comparison, we use ferric chloride to test the presence of phenolics. Firstly, add extract and distilled water, moreover, add HCl and magnesium powder. If the color of solution turns red yellowish, then saponin is present in the extract. Both secondary metabolites use FTIR to help find the functional groups which lead to the identification of secondary metabolites.
Next is to determine the maximum wavelength for the making of the cholesterol standard curve through UV visible spectroscopy. First, we measure the cholesterol powder and evaluate the measured value of cholesterol to make a standard cholesterol solution of 1000 ppm. Then the solution was placed in a test tube wrapped in aluminum foil to be vortex so that the cholesterol will dissolve in the solution well. Next, 2 ml of ferric chloride and 1 ml of sulfuric acid is added. Take note that the solution is vortex after each chemical is added. Then determine the lambda maximum at 400 until 700 nanometer. After obtaining the maximum wavelength, then the next step is to construct a cholesterol calibration curve. In this process, we prepare 9 solutions which consist of 5 ml of 96% ethanol blank solution and 8 solutions of different volume concentrations of cholesterol 1000 ppm and 96% ethanol. Each of these 8 solutions are also added with 2 ml of ferric chloride and 1 ml of sulfuric acid. Next, we tested each solution for absorbance with the maximum wavelength that has previously been obtained. The next use of UV visible spectroscopy is to perform the anti-cholesterol potential test. The rambutan leaves extract is each measured into 0%, 0.5%, 1%, and 2% of a 5 ml volume of cholesterol 1000 ppm standard solution, and at the same time to produce different contents of cholesterol in each of the resulting solutions. The resultant solutions will then have their absorbance tested using the UV visible spectrophotometer with the maximum wavelength.
Let's talk about the result of the secondary metabolites. The result of flavonoid identification can be seen by the previous solution of brown turning into black, indicating there's flavonoid. The FTR result also gives us a new perspective where the functional group of flavonoid, we all know that is O ether bond, C double bond C aromatic, C double bond O ketone, C double bond O conjugated acid, CH alkanes bond, and OH alcohol bond that's present in the extract too. The ferric chloride test shows the change of color from brown to orange, indicating the presence of saponin. Lastly, we have the FTR result where the phenolic functional group that we all know are CO alcohol bond, CO ether bond, C double bond C aromatic bond, C double bond C bond ketone, C double bond O bond ketone, C double O bond ketone conjugated acid, CH alkanes bond, and OH alcohol bonds that's also present in the extract.
Now we have the result of the maximum wavelength for the determination of standard curve and the result for cholesterol standard curve. On this first graph, we can see the maximum wavelength lies in the wavelength of 575 nanometer, with the highest absorbance of 0.864. The second graph shows the cholesterol standard curve on the wavelength of 575 nanometer, as well as its trendline equation. Next is the result of the anti-cholesterol potential test. Solutions had their absorbance tested with a wavelength of 575 nanometer using UV visible spectrophotometer as mentioned previously. Based on the graph, the 0% FF solution with 7.78 ppm cholesterol has an absorbance of 0.771, 0.5% with 5.22 ppm cholesterol has a 0.477 absorbance, 1% with a 4.21 ppm cholesterol has a 0.360 absorbance, and 2% with 6.68 ppm cholesterol has 0.645 absorbance. It can be seen from the graph that there is a decrease in absorbance and hence in cholesterol content in the optimum 1% rambutan leaf extract solution. From this, it can be concluded rambutan leaf extract have the potential to bind cholesterol. The conclusion of this research study is that rambutan leaves contain the secondary metabolites, flavonoids, and phenolic compounds that have the potential to suppress the high concentration of cholesterol in the body. Next, to extract the compounds by micronation, they identify the secondary metabolites present through phytochemical screening, UV visible spectroscopy, and FCIR spectroscopy. For future work, it is recommended to do in vitro and in vivo toxicity tests of the extract as an anti-hypercholesterolemia. For this research, we explored many sources to gain information. These are some references that we utilized for this research. And so that is all for our presentation. Thank you for listening.